Hello class. In this video, I'm going to show you how to construct a confidence interval for the population proportion. Let's look at this problem. A genetic experiment with peas resulted in one sample of offspring that consisted of 442 green peas and 163 yellow peas. We have two parts to complete. Part A, construct a 95% confidence interval to estimate of the percentage of yellow peas. Second part, Part B, based on the confidence interval, do the results of the experiment appear to contradict the expectation that 25% of the offspring peas would be yellow? So here, in this situation, we consider getting a yellow as a success. We have 442 plus 163, that is 605. We have that many number of trials. In other words, the sample size in this problem is 605. Firstly, you need to take notes when you read through the problem. Take notes. The sample size for this problem is 442 plus 163, that is 605. Number of successes, we have 163 yellow, so you want to use X. We use X to represent the number of successes. Number of successes. X here is 163, all right? If we use X to divide by P, then we would have the sample proportion. Sample proportion is around equal to 0.26942. So that's the sample proportion for the given sample with the size 605. Sample proportion is found by dividing number of successes, 163, by the sample size, 605, right? And we can also find a Q hat. This P hat is sample proportion. Q hat is 1 minus sample proportion, 1 minus P hat. Just use 1 to minus 0.26942 with 0.73058. To apply the formula to find the confidence interval, we need to look at the margin of error. We use capital E to represent margin of error. The formula to compute margin of error E is this formula. E equals Z sub alpha over 2 multiplied by square root P hat times Q hat all over N. We have already found the P hat. We also have a Q hat, which is 1 minus P hat. N is also found, is 605. So this part is taken care of. We need to know the value for Z sub alpha over 2, that critical value. The confidence level of this problem is 95%. It is given. The confidence level is 1 minus alpha. 1 minus alpha is the confidence level, which is equal to 95%. Then we can calculate, we can find the value for alpha over 2. If 1 minus alpha is 95%, alpha is 5%, then alpha over 2 is 2.5%. So look at this standard normal distribution. Z sub alpha 2 is the Z-score on the right tail. Z sub alpha 2 separate the area to the right that has the region to the right that has the area 2.5%. Z sub alpha over 2, since alpha over 2 is 2.5%, the region to the right of this critical value, the area of the region to the right of this critical value is 2.5%. That means the Y region, is 1 minus 2.5%. That is 97.5%. Be very careful. You need to know the region, the area of the white region. The total region has area 1, remember, because this is a density curve. If the shaded region has area 2.5%, then the blank region would have area 97.5% because they should add up 100%. 97.5% is 0.975. With the area found, you can use the TI-84 calculator. You do second VARS, VARS, and in the distribution manual, you need to find inverse normal, okay? Inverse normal. Use that function. Enter the area as 97.5%, as decimals is 0.975. Mu is 0, excuse me. Sigma is 1, because the standard deviation. No, sorry, the standard normal distribution. So use inverse normal to find the value of this z-score. It is the critical value, z sub alpha over 2. It is around equal to 1.96. So I actually just show you how do we find critical value by using the given confidence level. Is an important process. Start with make 1 minus alpha as the confidence level, and then solve for alpha. If 1 minus alpha is 95%, alpha is 5%. Half of alpha is 2.5%. That means that this score we're looking for separate a region to the right of it with area 2.5%. That means the region to the left has area 97.5%. Then we use the inverse normal function in TI-84 calculator, we can find the value for the critical value, which is 1.96. So you plug in everything. Z sub alpha over 2 is around equal to 1.96. P hat 0.26942. Q hat is 1 minus that P hat all over N. N is the sample size 605. So you can find this value. And you can find the margin of error. You add the margin of error on top of P hat. You have the right endpoint of the confidence interval. You subtract the margin of error from P hat. You have the left endpoint of the confidence interval. So that is how do we manually construct the confidence interval for population proportion. So as always, we have a shortcut. We can use a function in the TI-84 calculator to get it done very fast. Let me now show you. I need to first stop share this OneNote and share my TI-84 calculator emulator. So share again right here. Okay, let me show you how do we use TI-84 calculator function to construct the confidence interval. If you know this method, if you grasp this method, you can get the work done in seconds. We go to stat first, okay? Go to stat first, and then go to the right twice to select tests. In the menu of tests, we go all the way down to find one proportion z interval. Is the letter A here. The function we need to use is called a one proportion z interval because the critical value is a z-score, and we are estimated for a population proportion, one population proportion. So choose that function, and we need to enter the values for those entries. X, remember, is the number of successes. Getting the yellow piece is considered as success in this problem. So the number of successes is 163, is given by the problem. Sample size is 605. Add the two type of P's together, that's the sample size. C level, confidence level, 0.95. It is also given. Only 3 entries, right, to take care of, and then calculate. There we go. You will have this page, one proportion z interval, and that's the interval. This is the left endpoint, lower limit. This is the upper limit, the right endpoint. All right, you have to round it to the nearest if we keep 3 decimal places and the interval is 0.234, comma 0.305. Since 25% is 0.25, it fall between the confidence interval. We can say that the confidence interval includes 0.25. So the true percentage could easily equal 25%. Means the results of the experiment does not appear to contradict the expectation that 25% of the offspring peas would be yellow. All right, thank you for watching. I hope this helps.